Hello, everyone, and welcome back to the channel. In system design, dealing with vast amounts of data is a given, but how you process it effectively? Do you handle data in large chunks or as a continuous flow? This leads to a fundamental architectural decision, which is batch processing versus streaming processing. In system design interviews, understanding this distinction is crucial for designing data intensive applications. Today, we are diving into the core differences, pros and cons, and when to choose each for your data pipelines. Okay, the key difference between batch and stream processing lies in how they treat data and when they process it. If we want to talk about batch processing, like it's process finite, like it's finite bounded collection of data that have been accumulated over a period. Data is typically at rest in storage before processing begins. It's like doing your laundry once a week. You collect all the clothes and then the process them all at once. Okay. On the other hand, the streaming is quite different. Process it's in the streaming, the process is quite continuous, like unbounded streams of data as they arrive, data treated as in motion. It's like washing dishes immediately after each meal as they come. But I guess this is not just it has more complexities to it, so we need to take deep dive on each one of them separately. So if we want to talk about batch processing first, let's talk about the mechanism. The first thing about the mechanism, as you can see here, the data is collected, stored, and then processed in large batches, often on schedule, like nightly, weekly, monthly, things like that. And jobs read the entire data set or a large portion, perform computation, and write results back. The pros of this type of functionality: first, we have high throughput. It's excellent for processing very large volumes of data effectively and efficiently, as processing can be optimized for a throughput rather than latency. Number two, we have cost effective. You can utilize cheaper commodity hardware, and processing can be scheduled during off peak hours. Number three, it has simpler logic, often easier to design and debug as you are working with a fixed dataset. Number four, fault tolerance. It's easier to restore or rerun failed batch jobs from a known point. But what are the cons of this one? It has a high latency, and I would say this is the biggest one. It basically results are not available in real time. There is a significant delay between data in ingestion and processed output. It's not suitable for immediate insights. Number two, resource spikes, like batch jobs can consume significant resources, CPU and memory, during their execution window, potentially impacting other systems. Lastly, stale data. The insights delivered from batch processing are always historical. Like it's not up to date because it takes a lot of latency. Okay. Next, we need to talk about streaming. Let's talk about mechanism first. In streaming, data is processed incrementally as individual events or small windows of events. Events are processed almost immediately after they are generated. The pros of this one: it has pretty low latency, or we can say real time insights. It provides immediate feedback and insights as data flows through the system, enabling rapid decision making. Number two, responsiveness. It's ideal for applications that need to react instantly to events. Number three, continuous flow. It handles an unbounded streams of data gracefully. The cons of it: number one, complexity. Inherently, it's quite more complex to design, implement, and debug due to state management. I would say also out of order events and fault tolerance in a continuous stream. Number two, in the cons, I would say resource intensive. It often requires more dedicated resources to maintain low latency. Also, I would say it has some accuracy challenges because handling late arriving data or exactly once processing can be quite difficult. Um, I would say there is a common technology which is like Apache Kafka that be used like a streaming processor, and also in the batch you can like there is other things like in the batch like SQL batch jobs, or maybe Apache Hadoop, or like I would say Apache Spark as well. Spark, not Spark. Sorry. Okay. So, when to use which? When to use which? I would say you choose batch processing when you need to process large volumes of historical data. Two, latency is not critical and the insights can be delivered on schedule. Three, cost efficiency is primary concern on your application. Number four, in some use cases like end of day reports, monthly billing, payroll, deep analytics on historical data, data warehousing updates, all of that things. Also, you can choose stream processing when you need real time or near real time insights and immediate reactions. Number two, data is continuously generated and unbounded. Number three, low latency is a key requirement. Number four, use cases for, I would say, not, not number four. Number four, it will be the use cases. Sorry. It will be in fraud detection, live dashboards, stock tickers, personalized recommendations, IoT sensor data analysis, things like that. Okay, so let's talk about conclusion about that. So I would say batch and stream processing represent two fundamental paradigms for handling data. Batch excel at powerful historical analysis on data at rest, while stream thrives on extracting immediate value from data in motion. Understanding their strengths, weaknesses, and common technologies is essential for designing data pipelines that meet your system unique requirement for latency, throughput, and insight. This strategic choice is a key indicator of a strong system designer. So thanks for watching this video and see you in the future.